So you've probably heard this word ontology getting thrown around, right? Especially from tech giants like Microsoft when they're talking about AI and big data. It's one of those buzzwords that sounds super important, but what does it actually mean? Well, today we're going to demystify the concept that's quietly powering the whole next wave of artificial intelligence. And hey, if that's what you're thinking, you are so not alone. I mean, this quote, it comes directly from a professional who's trying to get their head around this very topic. It's a complex idea for sure, and it's really easy to get lost in all the jargon. But that's exactly what we're here to do, clear all of that up.
So yeah, these are the big questions we're going to tackle. We're going to break down exactly what an ontology is, see how it's evolved over time, and most importantly, figure out why it's suddenly this critical foundation for all the AI tools and platforms that are basically reshaping our world.
All right, so let's start right at the beginning. Before we jump into all the cool, flashy AI applications, we've got to get the fundamentals down. What are we actually talking about when we say ontology?
Okay, so here's the most important thing to get right off the bat. An ontology isn't the data itself. Think of it more like the rule book or a blueprint. It's the map that tells a computer how all these different pieces of information are actually connected. It's like this layer of meaning that gives everything context.
And that's really its main job. I mean, think about it. We live in a world with just mountains of data coming from everywhere. Spreadsheets, databases, random text documents. An ontology is what creates consistency. It makes sure that when one part of a system says customer, another part of the system knows exactly what that means. It's how you turn all that messy, chaotic data into something you can actually interpret.
So to really wrap our heads around this, let's start with the most basic kind of ontology, one that you're probably already using every day, even if you don't call it that.
Yeah, we can call this the hierarchical model. It's basically just a classification system. You start with something super broad, like vehicle. Then you narrow it down to a category, like car, and then you get to a specific instance, like a Tesla Model 3. See? It's neat, it's organized, and everything has its own little spot in a clear top-down hierarchy.
And this model is everywhere. Think about the library or just the folder system on your computer. They all use this simple parent-child structure. But here's the catch. Its biggest strength, its simplicity, is also its greatest weakness. It's just rigid. It can't easily show that a Tesla is not just a car, but it's also an electric vehicle and a product made in the USA. It just doesn't have the flexibility for those richer, more complex relationships.
So obviously, we needed an upgrade from that simple hierarchy, right? As data got way more connected, especially with the internet, we needed a much more powerful model. And this is what led to the next big evolution of ontology.
And this brings us to what we could call the web model. The huge shift here is moving from just slapping labels on data to actually defining rich, dynamic relationships between data points, and in a way that machines can actually understand. So it's not just a digital filing cabinet anymore, it's a true web of interconnected ideas.
And you see this model in action every single day. You know when you search on Google and that little box pops up with a person's birthday, their movies, their family members? That's an ontology at work. That's Google's knowledge graph. Or when an e-commerce site suggests a product you might like? Yep, that's an ontology defining the relationships between items. It's all built on standards like RDF and OWL, which are kind of like a common grammar for the web, making everything just a little bit smarter.
And that brings us to today, and the most powerful application yet. This is the moment where ontology goes from being just a useful tool for organizing stuff to becoming the literal backbone of modern AI.
Just think about it for a second. An AI can have access to all the data in the entire world, but if it can't see the connections, how a company, a person, a location, and an event are all related, that data is just a chaotic mess. It's basically pure noise.
This is where ontology comes in. It's the structure that connects all those dots. It builds the knowledge graph, that web of understanding that lets an AI see the world not as a list of disconnected facts, but as a complex system where everything is interconnected.
And here is the ultimate payoff. By providing all this deep relational context, ontology transforms raw data into a structured knowledge base. And that is what allows an AI to move beyond just matching patterns and actually start to reason, to infer, and to make decisions. This is how an AI gets a brain.
This is what we'll call the AI model. And honestly, it's a complete game changer. It's built to handle incredibly complex, constantly changing relationships, and it plugs directly into machine learning and natural language processing. This is the tech that's behind AI assistants like Siri and Alexa, and it is at the very heart of these massive enterprise platforms from companies like Microsoft and Palantir. Okay, so to see this in the real world, let's look at a concrete example. We've got two titans of the data world, Microsoft and Palantir. They both use ontology as the core of their big flagship platforms, but they do it for very different strategic reasons.
So, at a high level, you can see the difference pretty clearly. Microsoft Fabric is all about broad, enterprise-wide integration. It's designed to pull together data across an entire organization. Palantir Foundry, on the other hand, is built for these really specialized, high-stakes, mission-critical situations, where real-time decisions are everything.
Microsoft's whole play here is to leverage its massive existing ecosystem. Their ontology inside of Fabric IQ is all about creating a single source of truth by connecting data from tools that businesses are already using, like Power BI, Synapse, and Office 365. The goal? Unified analytics for the entire company.
Palantir, though, carves out a totally different niche. Their ontology is designed for the most complex environments you can imagine. We're talking government, defense, global logistics. For them, the focus isn't just on analytics. It's about enabling immediate operational decisions in situations where the stakes are incredibly high. It's all about acting on insights right now.
All right, so we've gone from a simple filing system all the way to the brains of AI that are powering global corporations. Let's just bring it all home and talk about why this concept is so incredibly important right now.
Ultimately, it really just comes down to this. As our data gets more and more complex and our AI gets more and more powerful, that bridge between them becomes more important than ever. Ontology is that bridge. It's the technology that lets us find the signal in all that noise.
You know, it's just not enough anymore for data to be available. It has to be smart. And ontology is what provides that intelligence. It ensures that when an AI or data analyst looks at a pile of information, they're not just seeing a sea of numbers and text, but a coherent, usable model of reality.
And this leaves us with one final and pretty crucial thought. An ontology is, at its heart, a model of the world. It defines what things are and how they relate to each other. So as we build these brains for our AI systems, the choices we make when we design these ontologies, well, they're going to have some profound effects. It leaves us with a critical question. As AI understands more of our world through these structures, who gets to decide what it all means?